What I'd like to do in this next example is show how to write your own filter function. So just as a reminder, this is how you use filters. So we could say, well, let me create a function first. So we define the function name is even like this. And if you've ever written this before, you just use the modulus or modulo operator. So what we're going to do is determine if the given integer is even or not. And because we're returning something that's true or false, our return value here is going to be Boolean. And then all you have to do with the modulus operator is say, well, if I modulus 2 is 0, and that's actually the entire function. And if you wanted to write it longer, you could say, well, if I modulus 2 is 0, then that's even. So we would say true, otherwise false. But it turns out we can just write this part right there like that. And then to apply this in Scala, we just say, well, what you want to do is use the filter function on x of s. So we say x of s dot filter, and then is even. And I save that. And it would help if I had a little output. So let me do a print line on y of s right there. And there we see that out of this input list right here, 1 through 5, the two even values are 2 through 4. So far so good. That's how you use a built-in filter function. Now let's get rid of that, and let's assume that we live in a world where filter doesn't exist, and we need to create our own filter function. And I only want to do this for integers right now, so we want to take in, this is going to have to work differently because this is a standalone function. So you can imagine that's going to be something like val y of s equals filter. And then what I'm going to do is pass in that list x of s, and then I need to pass in some filtering function right here as the second parameter. And the reason I mentioned that is because we're going to come up here and write our own filter function. And what we'll do, I'll call this one list. And I'm just going to start with a list of int, as I mentioned. And then this is going to be a filtering function. And now what we need to do is think about this type signature over here. And I probably should have left that code up there before, but what I had before was x of s dot map. And then I had is even was the way I was doing that. So it was val y of s equal that. Sorry, we were doing filter and not map. And this tells us that filter takes in a function like this. So in this particular case, our list is a list of integers. So what we need is a function that looks exactly like this one right here. It's a function that takes in one integer and returns a Boolean for that integer. So if you're not familiar with the way filter works, it marches over a list like this and it says, is this one even? No, that's false. Okay, is this one even? Oh, that one's true. Okay, let's return this one when we're done. Is this one even? Nope, that's false. We're not going to return that one. Is this one even? Yes, it is. We'll return that one, and so on. So it just marches through this list. But the filtering function you give it is even, just works on one element at a time here, then here, then here. So as you can imagine, there's a for loop going on inside a filter. And what I just mentioned was that the function signature looks like that. So we can just copy that one and paste it right here. And then just like I did before, we just need to make a few changes to that. So we could say, well, we take in one integer parameter, and then we just need to change that to that symbol like that. And that is how you type the type signature for this filtering function. And now the way filter works is that it's given a list like x of s, and it's going to return a new list y of s. And y of s is going to have the exact same type of elements as x of s. So if this is a list event, this is going to be a list event here. So then we can come up here and put that type signature and say, well, that's going to be a list event. And now we're ready to work on the function body here. As it turns out, this isn't going to be too bad. As I mentioned, we're going to need a for loop. So we're going to say, well, for every int I in that list event list. And now what I want to do is format this a little bit differently. And then I want to say if that filtering function on I is true, then we want to yield I. So hopefully by now you've written your own for expressions, and that made sense. So again, for every I in that list of integers, if the filtering function returns true when it evaluates I, then I want to yield that value I. If it's false, then what happens is this does not come down here. It doesn't yield that one. So it'll skip over values like 1, 3, and 5 in this example. And as I mentioned in previous videos, you could think about this as having a then keyword here. It does not have the then keyword, but if you want to think about it that way, that's the way that works right there. So now we should be able to come down here, and if I didn't make any mistakes, now this is our filter function right here. I can press save, and we're not going to see any output. Oops, except I made an error. Our filtering function needs to be is even in this example. And also I need to print that output was the other thing I need to do. So let's put that in there as well and save that. And there we go. So we have a list of 2 and 4. And now this is using our filtering function, which I just wrote right here. And we did that by passing in a filtering function right there. One reason I'm showing this example is because this type signature right here is different than what I used in the sum and multiply example. So I want to get you used to seeing different type signatures over here. Another thing I want to mention is when your function, the filtering function in this case, only has one input parameter, you don't need those parentheses right there. So I can save that. And you'll see that we get the same result right down there. But I tend to keep that in there just as a reminder to myself that in different circumstances, we may have multiple input parameters. But again, when you only have one like this, that isn't required. And I was going through all that because what I want to do is get you used to reading type signatures in the Scala doc. So this is a portion of the Scala doc for the filter method. I think this came from Scala 2, but the important part is that it shows the type signature right here. So it's showing the input parameter name is P, followed by that colon right there. Also, if it helps to know, anytime you see a P in the Scala doc, that's referring to a predicate. And a predicate is just a function that returns a Boolean. So filter is saying it takes in this input parameter named P, and that is a function that should transform any type into a Boolean. And this is working with generic types right here. So what happens is when you're working with a list of integers, like we are right now, then A would be considered an int here and here. So the way you read this is the filter method on the list takes in a function. That's the first thing you should look at and see is you're seeing one type being transformed into another type here. So as soon as you see that, you think, oh, okay, this is a function because of that transformation symbol right there. And because we're working with int, this function that you're going to pass in must transform an int over into a Boolean. And that's exactly what is even does, is it transforms this input int into a Boolean. And that's why it works with our filter example. And now if I go over to the real Scala doc for Scala 3, you can still see the same type signature. So this is where it gets interesting, and where I was talking about you'll now be able to read the Scala doc better, is anytime you see that transformation symbol right there, you can think, oh, okay, this is a function input parameter right here. So again, it's called P, and this function must transform an A into a Boolean. And again, because we're working with a list of int, that means it must transform an int into a Boolean. Exists has the same type signature, so you can read that one and say, oh, okay, exists also takes a predicate with the same type signature for it. If I scroll down, filter not is also the same, find is the same. Flat map is an interesting one because it takes a function, which you can see here, transforms the A, which in our case is int, into an iterable once of a different type B. And that's where that gets interesting, is right there. And I should mention an iterable once is something like a sequence or a vector or a list. If you want more specific types right here. And let's keep scrolling down. So for all takes the same type signature as filter. For each is an interesting one. Now this one takes, you could tell it's a function again because of that transformation symbol. This one uses the U. So U typically stands for unit. So for each is something you would use with println, and it transforms an A like an int into a unit right there. So println is a good example of that one right there. So here we could define our own function. We'll just call it P for print. Well, I don't want to get that confused with predicate, so how about call it put? So we'll take type any right here, and then we're going to transform that into a unit. And then this will println that A. Okay, so now I have something going from A of any. So now this is similar to that for each signature right there. And actually, let me change that back to int just for this particular example. So we could do that. I want to keep this type here consistent with the type that's in the list. So now if we come down here, we could say y(f(s).for each, and then we could say put, and I'll save that. And now come down here, and we see that output right there is 4 and 2. And if I change that to x of s, you'll see that it does all 5. So that's working right there. So again, the way you would read for each is it takes a function input parameter, it transforms whatever's in your list, and in our case, that's an int. That's why I put that int right there. And it transforms that into a unit. And that's why this one has the unit return type right there. And because put has that type signature, we can use it inside of for each right there. And scrolling along, by now you're becoming a pro at this, so you can look at the same thing for the map function right here. It's very similar to flat map, except where flat map had an iterable once of b over here, map is a function that transforms an a into a b. That's all that that says right there. So for our example, we could say something like, well, how about if we take x of s, and then we say map, and I want to transform each element I into some other type. So I is an int. I can't remember if you could use this syntax. So we have I. I is an int. We're going to find out in a moment if that works. And I want to transform that I into, how about I.to double? And save that. Let's see if that'll work. No, it does not work like that. Save that. And would help if I put a print line there and there. And there we see the output now. So what I did here is this is a function, or more specifically, that's an anonymous function, and it transforms this int I into a totally different type over here, double, and that matches this signature right here, where A is the original I, and now B is a double in this particular example. And if you care to see something different, we could also transform that into a string like that. And this is where the REPL doesn't quite work as well as I want it to, but these are actually now strings here because of this syntax that I've used right there. I believe there's a way to make that show better. And I'm sorry, I said REPL, but I meant compiler. This is the way the compiler is showing these strings. I wish it would put the double quotes around here, but it doesn't work that way. But this does show now that these are strings. So again, I'm just mapping right here. And now at this point, if I were to keep scrolling through here, you would see that you could probably read many, many, many of these function signatures in here. And the only ones you may not be able to read are some of these that use these other symbols right here. So you can tell over here that this is a function that goes from A to B. But in terms of this video series yet, I haven't explained this part yet. So that's the type of thing that might not make sense yet. And this part right here and this one here. But other than that, if you look at all these function signatures, you'll start to be able to read all of these right now as terms of these higher order functions that take other functions as input parameters. And again, as a summary, we just created a filter function in this video, and I did that to show how to pass in a function input parameter that has a different type, and then how to use that inside of a for expression like this.